The term internet means interconnected networks, but the internet is different than our local network, which allows us to connect all of our production devices together. A network that was required to connect to this global thing we call the internet. Today, we're taking a look at how a network works, starting at the internet service provider, giving your network internet, all the way to controlling your PTZ cameras through your local network. If we have not met, I'm Nathan from Crazy Amazing Designs. Let's get started. Internet access is purchased from an internet service provider. Xfinity is a big name. Coax cable or fiber optic cables are the two ways the internet is connected into your house or business. Once inside, a cable modem or an optical network terminal for the fiber box is required to turn the signal into Ethernet. We're going to leave the fiber connection here for the sake of this video, but the coax will connect to a basic cable modem. The modem contains two connections, coax for the input and an RJ45 port for internet. To build the smallest network possible, I'm going to connect my laptop to this WAN port, which stands for Wide Area Network. This single laptop will receive an IP address straight from the internet service provider, who provides one public IP address per address. If you ever want to know your WAN address on the network you're connected to, go to ipchicken.com to find it. Keep this address a secret though, as this is your link to the global internet. Here is an example address. Instead of connecting the laptop straight to the global internet and being limited to one total device, because that's how many IP addresses we pay for from our internet service provider, we need to include a router, which is the traffic director between the internet and your local network. Often the ISP will provide a convenient modem router combo with built-in Wi-Fi. This is all that most homes are going to need, but most internet service providers charge around $15 per month for this box, so I would recommend buying one as it pays for itself in the first year. Check the video description to find links to my recommendations. A router connected to the WAN, the wide area network port on the modem, uses the IP address from the internet service provider to receive internet. Then it creates a local area network with an IP address scheme that might look like this. This local network allows devices to communicate within the local network and connect to the world through the WAN port. Most basic routers that you might buy for your house have one WAN port that connects to the modem, and it also has 4 LAN ports to connect computers, printers. Then it also has a built-in access point which broadcasts Wi-Fi signals so that other devices can connect. Routers manage the local network and our connection to the worldwide network. Because it's also a device on the LAN network, it needs its own IP address called the gateway IP. It also receives a public IP address from the internet service provider, which manages the whole worldwide network connection to the servers that make up the internet. On the LAN side of things, devices connect to the router via Ethernet or Wi-Fi. Each of these devices needs an IP address which uniquely identifies the device. We might look something like this. DHCP is the protocol that runs on routers that provide connected devices with an IP address. Routers do other stuff like manage the flow of traffic, but technically switches do also. When I say router, I'm primarily talking about the responsibility of running a DHCP server to hand out IP addresses. That's why it's so important to only have one router connected to your network. If you need more Wi-Fi sources, then you need additional access points. Larger networks separate these devices. For example, this is our Netgear AV router, and this is our Netgear AV access point on our production network at my church. But consumer gear often builds them into the same unit. When you go to configure these devices, it will ask if you want to set up the device as a router or as an access point. Access points broadcast SSIDs, aka Wi-Fi, that users can connect to. You can add multiple access points, and you can even set them up to broadcast the same SSIDs, which is useful so users can move around the building and not have to keep connecting to different Wi-Fi SSIDs based on where you're at in the building. How many access points you need in your building depends on stuff like building layout and number of users. Building a mesh Wi-Fi network for your building is a whole other conversation that requires a commercial system like Ubiquiti to properly control connected users to make sure that they're connected to the strongest access point. In a future video, we might cover this, so leave a comment if you'd like to hear more. We could also talk about broadcasting multiple SSIDs throughout our building so that we can have the staff Wi-Fi and the public Wi-Fi. This requires separate VLANs, virtual local area networks, that allow us to separate that traffic. That way we can limit the guest users while the staff Wi-Fi is able to function at full speed. Beyond that, I think it's best to completely isolate the production network from the rest of the building's network with its own routers, own access points, own switches. These are mission critical systems that can't fail because someone decided to download the whole entire app store during service. At our church, we have Wi-Fi that can be accessed from anywhere in the building without the limits of having an Ethernet cable running to the device. When we start looking at live production, we find these mission critical devices that use Ethernet as a reliable form of transmitting data from point to point. I've painted this image of how a network works, where we currently have a modem, then the router, but it's limited to 4 LAN Ethernet ports. In my router, we have 2 office computers, 1 printer connected to the router. We also ran a long Ethernet cable from the router to a computer at the sound booth, the front of house position, whatever you call it, where a ProPresenter or equivalent presentation software is running. Now, with these 4 devices on our router is full. We need to introduce our first network switch. Switches can be anything from 4-port, 8-port, 16-port, up to 24 or 48 ports as 2U rack-mounted units. I'm going to disconnect the 4 LAN cables from the router and connect them to ports 2 through 5 on this switch. Then connect port 1 to LAN port 1 on the router. This is an 8-port switch, so we can still connect 3 more devices. Now we can connect a lot more devices to the network through this switch. Switches connect devices inside of the same network. Any of the devices connected to this switch will be able to communicate with each other or with the internet because of port 1 connected to the router. This switch has now become the central network hub for all devices in our network. Even if this was a 48-port switch, you would eventually fill this switch. Plus, the max length of copper Ethernet is 300 feet, so it would be crazy to run a 300-foot cable for every device you want to connect to this network. That's why we're going to build a basic star typography network where this is the central switch. Then we're going to connect additional network switches in other key areas of our building. We're going to have trunk ports that connect the switches together. Then access points can be connected to any port on any of our network switches. So let's go back to that Ethernet cable we ran to the front of house booth that is connected to the presentation computer. For expandability, you could connect this Ethernet cable to a network switch and connect all of your devices to it. I'm the production director at my church, and on our production network, I have moved that cable from being connected to a single computer. I treat the building network as our internet service provider. I've connected that building link cable to the WAN port on a router. Then I connected one of the LAN ports on that router to a switch. That is my main network switch on our production network. That main switch connects in a star typography to 5 other switches on our production network. This allows us to communicate between devices across the 6 switches located in key areas of our space. We have the stage, we have the front of house audio cart, we have the front of house video cart, we have the control room, and we have the amps room. Internet is access to the outside world, whereas network is the transmission of signals between devices. Usually if there is a network connection, then there's also access to the internet. Here I have 4 PTZ cameras connected to our network. Each camera is connected via SDI to our video switcher, but each of them also have an Ethernet cable to our network for power and remote control. With the PTZ controller also connected to the network, we can remote control, pan, tilt, and zoom these PTZ cameras, which they don't need access to the internet, but they do need to be on the same local network to talk to the controller. Our building network is completely isolated from our production network, and this allows us to manage systems like Dante in a way that normal networking systems don't really like. Dante does not play well with other traffic and likes to be isolated, but we also want devices to be connected together so that we can use ProPresenter Remote or control devices with BitFocus Companion. I do have some VLAN, some virtual local area networks set up to break up our network into systems, so we can talk about more of that in a future video. Our church pays an outside company to provide us with IT management services. They control our building's internet, Wi-Fi, as well as end user issues. They also do help desk type stuff. It's amazing. Then I manage all of my own devices on our production network, completely separate from the rest of the building. This way I can control systems that allow me to control what is going on while they handle normal IT, which is so completely different. I hope this video has given you a much clearer picture of how networking systems work, starting with the internet service provider cable coming into your production rack. There are so many layers to the scale and complexity, but every facility or home has the same core infrastructure, even if it's smaller. Thank you for watching this video. If you found value in this content, please consider subscribing to see future videos. I do offer Zoom training sessions where I both teach and help users solve problems. Networking is a topic I'd be happy to help with. Find a time that works for you on my calendar at crazyamazingdesigns.com/training, and I will see you soon or in a future video. Have a nice day.